Hi, I'm Victor from Superfun Adventure Quest Time, also known as SFAQT.com. We're in the pre-show portion of our live stream. This is Hainita.
Hello, I need access, and I'm very happy to be here. We have an eclipse coming up, and today is our prototyping experience of the complete eclipse experience that we should be experiencing in about 48 hours. Welcome to our pre-show where we're getting all of our gear in order. I mean, it's already in order, but now we're double checking to make sure that everything is as expected. Because we are simulating the entire eclipse event, our show today should be over 2 hours. So prepare yourself for 2+ hours of fun and adventure.
And we're going to run Stellarium in real time. We're not going to be fast forwarding anything. We're going to simulate it as if it were actually happening.
Not familiar with Stellarium? Buckle your seatbelts because you are going to have your mind blown by this incredible free software that allows you to see many wonders of the universe.
This is our mission control room. You can see we have a screen in front of us where we can do various different things. There's a camera pointing down. You can see that where Anita's hands are. And that's where Anita's going to be filling out the logbook today. This is our eclipse tracking logbook. This allows us to plan exactly to the second when things are going to happen during the eclipse so that tomorrow we will not be surprised.
You can print one of these logbooks out for yourself on our website. And if you do not have access to a color printer, you can print one in black and white, which looks pretty darn cool.
Roger that. Yes. Hello, I'm Victor Criterion of Super Fun Adventure Quest Time. This is our Master Control Center. We're about to simulate an eclipse, the one that's going to happen tomorrow. We want to be prepared and know exactly when everything is going to happen. So we're going to go minute by minute in real time. We're going to configure our Stellarium for our exact location, and we're going to see what happens. This is...
Hello, I am Anita Excess, and I'm really excited to be here today. We're prototyping our complete eclipse experience about 48 hours before the real thing happens. We want to make sure that we are familiar with all of our tools, and we know exactly when all of the different events are going to happen, and we want to share this experience with everyone, so welcome.
Here we go. First thing we're going to do is configure Stellarium to have our current location, but we need to find that location. So we're going to go to Google Maps, and today we're going to be broadcasting from Enchanted Rock. Let's see, I see Fredericksburg. I see Llano. That means Enchanted Rock is about right there. And we're going to be on the south side. So our coordinates are... And Anita's going to fill out the logbook with those exact coordinates. Oh, don't forget today's date. And by today's date, I mean tomorrow's date, since... Oh,
We're going to use today's date.
okay.
Off button is over the latitude.
Roger that. And because everybody in the world uses different way of expressing the coordinates, we've written down the decimal degrees version. But in just a second, we're going to calculate what that is in degrees, minutes, and seconds, and what that is in degrees and decimal minutes. So what is our first number, Anita? I can't hear you.
30.503667.
And what is our longitude?
Negative 98.818960.
Okay, that gives us our degrees, minutes, and seconds in these two boxes. And this gives us our degrees and decimal minutes. Like I say, every single place uses a different version of those, and you never know which one they're going to ask for. So we're making sure that we write them all down. I'll provide a copy of this spreadsheet that tells exactly how these formulas work. Put that on the website. All right, do we have all those?
I've written down all three different numbering schema. First one is the decimal.
The other thing we're going to need is the altitude. So what is our location in decimal degrees?
30.503667 by negative 98.818960.
Do I have that correct?
Correct.
Our elevation is going to be 483 meters. Okay, so the next thing is we're going to set up Stellarium. Our location is what?
30 degrees by 30 minutes, 13.20 seconds. By north by 98 degrees, 49 minutes, and 08.25 seconds.
Like that?
That is correct.
What is our elevation again?
483 meters.
483 meters. We're going to save this as Enchanted Rock. We're going to say use this location as our default. We're going to add it to the list. So now we are in there. Do those coordinates look correct?
Verify. Longitude west, the last digit needs to be changed to 25, or rather, yeah. And for some reason the latitude got weird.
It's probably because we used more digits than it was using.
Okay, so it was 30 degrees by 30 minutes and 13.20 seconds. That looks good.
Everything looked good.
Yes.
Okay. And we're going to change our landscape to look like Enchanted Rock. There we are. We're going to be looking at the sun. And now we're going to change our date and time to be of the actual eclipse. And it is 12:07. Now really quickly we're going to have to figure out when these things are going to occur for us. We're going to go to this page. We're going to calculate our exact times for everything. We're going to make sure we switch this to April 8th. And what are our latitude and longitude in degrees and decimal minutes?
30 degrees, 30.220 north, and 98, 49.138 west.
Altitude.
483 meters.
And we are currently in UTC -6 west, and we're in daylight savings time. So here are exact numbers of when things are going to occur. And let me pull your screen back up.
Will occur at 12:16:05, and that's going to be in approximately 6 minutes from now.
All right, we better hurry.
Contact will occur at 1:33:25. Contact will occur at 1:35:38.
You need to move your paper up.
Contact will happen at 2:56:40.
Third contact looks off on the sheet. Third contact occurs at 1:37.
Totality begins at 13:35:38.
Okay. All right. You can record those altitudes and azimuths for each of those.
Okay, I'm going to record the azimuth and altitude of each one of these contacts.
Okay, the last thing we're going to look at is the prediction for Bailey's beads for our location. At C2, they're predicted to be on this side.
I'm going to use a pencil to sketch in the predicted Bailey's beads, and then when I see Bailey's beads, I'm going to use my pen to draw the actual Bailey's beads.
Affirmative. This is C2. And on this drawing, we've exaggerated the mountains on the moon and the valleys of the moon so that they're easy to see where they are, but they're not actually that big.
And C3 refers to the C2 refers to second contact, and C3 refers to third contact.
How long until our first contact? 2 minutes.
2 minutes, all right.
We need to record a pre-eclipse at the begin plus T's and get our what we're currently seeing.
Begin plus T at 12:14. Is currently 69 degrees Fahrenheit.
And that's because we're indoors right now.
The brightness is 735 lux.
All right, we're about to have first contact. I've switched into a mode of Stellarium that will represent what you would see if you're looking at it through a telescope. What we're looking for is over here. There's going to appear when the first contact actually happens. There it happened.
Oh, and I'm going to record the azimuth and altitude. Rather, I'm going to check the azimuth and altitude that I recorded earlier, and they are both correct. I'm going to check the temperature again and the brightness. The temperature is 69 degrees Fahrenheit. And we're waiting for the lux meter to settle down. Lux meter is 771.
Now we're going to be waiting for when the moon obscures the sun 1/8 amount. And that could be done in many different ways. It could be based on time, or it could be percentage of the sun covered. And in Stellarium, it gives us over here eclipse obscuration. And if you divide 100% by 8, you get 12.5. Is that correct?
That is correct.
So we're going to wait every 12.5 of obscuration, and we're going to call that 1/8 obscured. And we're going to use those numbers in our logbook. Since it goes on a percentage of the diameter of the sun and the moon, it's not going to be linear. The first 1/8 will probably be about 12 minutes past the C1. That gives us some time to do other things while we're waiting on that to happen. Let's see if we can see any sunspots.
Study of sunspots is a fascinating field or a hobby to get into. We have some links to various resources that should pique your interest in drawing sunspots as a hobby. And you know, your first step is to draw sunspots on our helpful log. And so we are going to look at the sunspots in Stellarium and take a look.
The ones in Stellarium, of course, are not real. It does not have access to real-time sunspot data, so it just uses a bitmap image to represent them, but we're going to draw them as if they were real.
We're seeing 3 sunspots today. Do you see any more? Is there one on the left there?
See if we can get a tighter view.
I see another one.
We look over here, we see that the center of the solar eclipse right now is at 8 degrees, 21 minutes, and some amount of seconds. Negative 120 degrees, 32 minutes, and some amount of seconds. So let's pull up Google Maps. Let's convert this number into a decimal, and we're going to see where the center of the sun is right now. So if you'll write down those in a notes field, Anita. What is the position right now?
The current position of the center of the sun is 8 degrees, 31 minutes, 20 seconds by north by negative 120 degrees, 20 minutes and 56 seconds west.
So that gives us 8.522. I'm going to plug those into Google and see where the center of that is. Google says it's out in the Pacific, southwest of Mexico. So it's got a ways to go until it gets to us. The shadow is going to sweep in this general direction, going straight across Fredericksburg and then up to the east.
A neat little factoid is that the eclipse is going to enter Texas at the border at a town called Radar-based Texas. Can't imagine what they do there.
Well, it looks like there's a radar base there.
Certainly does. Been to Radar-based Texas, and now that I know that it exists, certainly it should be a place that we have in our future trip opportunities.
I realized we had that obscured with our master control camera when we did this exercise, so I'm going to redo it.
Like we've got some time.
So out in the Pacific right now. that makes me wonder if we had this obscured. I don't remember if we obscured it or not. But there are those numbers again, just in case. Another thing to look at on this one is the amount of time in totality. So no matter what, whether rain or shine, the amount of time you spend in totality is a very important number because there are leaderboards on the internet where you can enter the total amount of time you've spent in totality in your life and see who has been in eclipse totality the most.
Fascinating competition. I had, previous to this eclipse, I had no idea that people were tracking their minutes in totality. And it just kind of boggles the mind in a good way. What else could we be tracking like this? I don't know. We're waiting for the eclipse obscuration number to hit 12.5%. That will be our 1/8 contact. The eclipse obscuration is currently 5.3%. Now, I think I have seen at least one other total eclipse back in 19, the early 1990s in Mexico City. It was such a fantastic experience because you feel like you're in space, and the sun, which is just this glowing presence that's been with you your entire life, just disappears, and you can see stars in the middle of the day, and then to see the corona and the diamond ring. I mean, you suddenly feel your place in this cosmic universe. It's very awe-inspiring, and I can't wait until, because hopefully we can have that experience again. One of the reasons we're doing this live stream is because we invited 30 people to our eclipse watching party, and then a state of emergency was declared because of the expected terrible traffic, and everyone canceled. So this live stream is for all of our friends who are unable to come to our eclipse party. And of course, you, the general public, who was not invited to our eclipse party but can still benefit from the information that we're sharing today.
We are currently at 8.7% obscuration. We're waiting for 12.5. While we do that, we're going to look at the current eclipse leaderboard. Once we find it. We're at 11% eclipse obscuration. Once we find the URL for the leaderboard, we'll bring that.
I'm going to take a note of the time and the azimuth and altitude, as well as the temperature and brightness, but the time, altitude, and azimuth are the most important things to note first.
%, 12.1. It's time to get excited. Something's happening. 12.3. 12.4. 12.5. I'm going to see if I can turn off those bouncing rings, the crosshairs that are on the sun. There we go. That was Control-Shift-P in Stellarium. Alright, next we're waiting for 25 on the eclipse obscuration. It'll be another 10 minutes or so. I have the website for the Eclipse Chaser, eclipse-chaser-log.com. You can see the time in totality and the time in annularity is very important. And if you look up who this person is, you'll find that he is a very important person in astronomy. Let's see his Wikipedia. No, that's the wrong person. No, maybe that's not who I thought it was. Anyway,
What the important thing is that Paul D. Maley has seen 83 eclipses, and his time in totality is 1 hour and how many minutes? 12 minutes. That shows you how fleeting totality is.
and since we're going to be in totality for 4 minutes and 30 seconds, it's quite impressive.
We're going to get a jump start on our minutes in totality. It's very exciting. Over an hour of totality means that you must have seen many, many, many eclipses, because most eclipses are less than 4 minutes. So it's very hard to get over 60 minutes of totality during a lifetime.
Here's the person that I thought was number one. Was 79 years old. Now we're looking for 25% obscuration. We're getting closer. As each one of these happens, it's going to get closer and closer together time-wise, because we're dealing with two spheres. What other kind of equipment do we have, Anita?
Well, today we're using this light meter that we got off of Amazon. Currently measuring the light in a dark room, but on Monday it will be measuring the full brightness of the sun.
The important thing to know about light meters are they are notoriously inaccurate. Anything can change it. If you're wearing a black shirt and you walk near it, you could be obscuring some light. If you wear a white shirt and walk near it, you'll be adding light. The slightest movement, left, right, up, down, all cause it to fluctuate. You can see as Anita moves it around just how wild the readings get. Measuring light is a fun subject.
On our web page, we're going to do a project where you use a smudge of grease to help determine how bright the sun is
Relative to a 100-watt bulb. There's a link on the website that sends you to someone who's done that project, and you could probably build one on your own.
Another tool we're hygrometer, although we're not tracking the moisture in the air. During the eclipse, the temperature will drop rather dramatically as the light disappears from the sky, and then after third contact, the temperature will start to rise as the sun comes back. It's quite a fascinating experience, and so I strongly recommend that you have a thermometer in your toolkit of eclipse tools for Monday.
And when you read the temperature on the National Weather Service, keep in mind that the temperature is the temperature in shade. When we are taking these readings, we put it the temperature in sunlight. So our amounts are going to fluctuate much larger than what you would expect when you read it just in the shade. During the last eclipse, which was an annular eclipse, we saw the temperature fluctuate 20 degrees in sunlight.
We are at 22% eclipse obscuration. This is really exciting. Only 3% more to go before our next logging opportunity. At this phase of the eclipse, I will be giddy with excitement because the sun looks like it's being devoured by the moon one bite at a time.
%. After this event, I think we will look at where the center of the shadow is again. 24.2, 24.3, 4.4, 24.5, 3, 2, 1. 25%.
All right. So
If you'll make a note of these numbers for the center of the solar eclipse, we'll see where it is. We're going to use our handy spreadsheet again. All right. What is the latitude? I can't hear you on the radio.
15 degrees, 41 minutes, and 50 seconds.
And what is our longitude?
Negative 112 degrees, 59 minutes, and 40 seconds.
I'm going to zoom in and give it those coordinates again so that we can see exactly where it is. Right there in the Pacific Ocean, but you can see it's much closer to Mexico now.
I wonder how many cruise ships are going to be in the Pacific Ocean chasing the eclipse on Monday.
Let's hope all of them.
So the next series of numbers that we're going to be making a note at will be, oops, hold on, I forgot to write the temperature and the brightness at 12:43. Hold on, let me correct that. Look, it's 70 degrees in here. And 509 lux. The next note-taking opportunity will be at 37.5%. So it's going to be, much sooner than the last series.
Go ahead, let's talk about more equipment.
We're going to, we have more tools to show you. This is our Hemisphere Solar Tracker. It's a project on our website that you can 3D print. Globe is something you can order off of Amazon.
It's a Christmas ornament.
There is a swing arm, which you use to find the altitude of the sun. These readings were taken on March 19th during the equinox.
I will illustrate by providing a fake light. See how the shadow obscures in the very center, the phone representing where the sun is, and during each time we went out and took a reading, Anita would place a dot where the sun was casting a shadow exactly there.
This is a very fun tool to get an idea of the path of the sun across the sky. We're going to be tracking the equinoxes and the solstices this year, as well as on a separate dome, we're going to be tracking the eclipse. And once a month, we're going to see where the sun rises and falls, and sets, and its path across the sky.
If you look at the current altitude and azimuth of the sun, if you visualize that, you can see where it approximately is using the hemisphere solar tracker. So if you set your azimuth to 152 degrees, and then you look up on the swing arm at 64 degrees, that will show you about where the sun is in our sky right now.
So the sun is about right there in our simulation.
What's our obscuration we're looking for?
37.5%.
All right.
Close. Our hemisphere solar tracker also has a compass and a bubble level to make sure that your measurements are accurate.
We're at 36%.
Time is just flying by today. This is just so much fun.
Thirty-six point 36.7, 36.8, 36.9, 37.
Temperature is 70 degrees. The brightness is 987.
And what's our next target for obscuration?
Our next target is 50%. 50% until the time left to totality. Oh, I can hardly wait. Now we will show you the most important part of the eclipse watching experience are the eclipse glasses. I learned earlier today that in the 50s they didn't have eclipse glasses, and so people would take a piece of glass and put a match under it, and they would blacken the glass with the flame from the match, and then they would look at the sky through, they would look at the eclipse through that.
Probably not a good idea.
It's amazing that generation didn't blind themselves. So we have to be very thankful of these incredible eclipse glasses that are now available to us for under $2.
What's the most important information on the eclipse glasses?
Most important information is whether it has the stamp that it's ISO certified.
And then there should be an ISO number somewhere on them, telling you which ISO that it follows.
This says this conforms to and meets the transmission requirements of ISO 12312-2, filters for direct observation of the sun. And then you also have the C space E, which is another important mark on your solar glasses.
That one also has a stamp saying it's made in the USA. We got those at HEB.
And eclipse glasses can be used to stare at the sun not during an eclipse.
But maybe not to stare, but to glance at for a few seconds or so. Even with eclipse glasses, it's probably not a good idea to stare at the sun for very long.
If you want to take a photograph of the eclipse, be sure to put your eclipse glasses over the camera of the eclipse.
Of the phone.
Of the phone, excuse me. That would be this part. And then hold it up to the sky and take your photo. But we strongly recommend that during totality, don't bother to take photos. Just glance at the wonderment of the events, the celestial events, the cosmic dance happening above your head, because there'll be a million photos on the internet, and so get your eclipse photos before and after totality, but just
enjoy totality. We're at 45%.
5% left to go until 50%.
%46%. I'm going to try switching the ocular, see if we can get a better view. There we go. We're at 48%. %49%. We're almost at 50% obscuration. $49.5. $50. The numbers that we're collecting right now will be useful on the day of the eclipse so that you know exactly when all these things are going to occur. You can use the guidebook that you're filling out now as a way to know when they're going to happen. You can also take a second guidebook, logbook, and fill it out as the things happen on the day of.
We strongly believe in prototyping the experiences, important experiences such as eclipses, so that you have a really good idea of how things are going to go, and yet you'll have time to be blown away by the marvels of the universe while still maintaining structure.
And what is the next point we're looking for?
62.5%. So our data logging is going so well because we know the exact latitude and longitude of our specific location. And so I strongly urge you to find your latitude and longitude so that you know to the minute that the first contact, second contact, third contact, and fourth contact will be happening for your area. This is just the most critical piece of information for this whole exercise is figuring out your latitude and longitude so that you can get a schedule of these events in your specific location.
Now, someone in a group may have a bright idea that they want to use a telescope and that they have not bought a thing to cover the telescope yet. And what can happen is they will think that you can put the viewers at the eyepiece, the same glasses that you would have used. Make that bigger. And that is not a good idea. And that is not a good idea because the entirety of the sun will be focused right onto the lens of the glasses. Very, very bad idea. It's like trying to start a little fire with them, because what will happen if you see that, that is someone who's actually tried to do that. And you notice there's little tiny holes that have been burnt into the eclipse glasses. That they may also have little black spots in their eyes because of this. Do not do that.
If you are going to use say, a pair of binoculars, you would need to, you would put the...
You need to purchase, there are devices specifically for that that you put over the large side of the binoculars or a telescope. But you need to get those well in advance.
The paper eclipse glasses aren't your style. You can always take a pair of sunglasses that you already own and tape the eclipse glasses to your... These are taped into so that the arms don't fold right now, so they're kind of hard to see. But this is a specially made pair of eclipse glasses that are more robust and won't be blown off your face in case the wind goes up.
We were picking up some static there during that. I guess I can't fold those arms. Those are my personal eclipse viewing glasses. You can also hold them up to the other camera if you provide a light for them. Let me make that a little bigger. All I've done was tape the eclipse glasses over my normal goggles that I wear for any day. That way I can see the eclipse just fine and not have the side light coming in.
We are at 60% eclipse obscuration, and we are looking for 62.5. It's coming very soon.
'61. We're looking for 62.5. .2, .1, .2, .3, .4, 62.5. Altitude is 66.
The temperature is 70 degrees. a square out of tape on our table and set the lux meter, the light meter into that same square each time, we might get a slightly more consistent reading.
Yeah, we should probably even put it on a tripod like everything else. Is there a tripod mount on that?
Not yet, but that doesn't mean that we can't make something happen.
All right.
You may have noticed that I tried to switch pins before that last reading or logging, but because my wonderful Sharpie S gel pen, which I use for many things, not the best choice for this logbook. This logbook is kind of a glossy coating, and so it means that the ink is taking a long time to dry, and it is smudging. So I may have to, and my Sharpie did not work, so I have to make sure that the Sharpie works, or I have to find a pen before a better pen before Monday.
And what is our next eclipse obscuration we're looking for?
25%. We've decided that I'm going to go find another Sharpie.
Please give us reports on your status.
Absolutely. Keep an eye on that eclipse obscuration number. We're looking for 75%, and I can't miss it. Entering the other room. I do not see any black fine-tip Sharpies, extra fine-tip Sharpies in this room. I'm going to have to look further out. Read me. I've gone deeper into the space.
Repeat.
I've gone deeper into the space, and I have found some Sharpies.
Perfect.
I am returning now. Eclipse obscuration. 75's coming up quick. I had better test out my Sharpies. I brought more than one in case the next one doesn't work. I have 3 opportunities. Found a Sharpie that works. I'm going to test it on this glossy paper.
How's the smudge factor just after writing?
No smudging.
Perfection.
It looks like it does not bleed through to the other side.
Incredible.
I think Sharpie, this Sharpie Extra Fine Point might be my new logging book writing instrument.
We're at 72%.
Have only 2 more readings until totality, or second, until second contact gets very, very close. Diamond ring, Bailey speeds, totality, and third contact at Bailey speeds and diamond ring all happen within 4 minutes, so it's going to be very exciting. We're getting very close now.
We're at 73%. Magic number is 75. $74. 74.5. 0.6. 74.7. 74.8. 0.9. 75%. $167 azimuth, 66 altitude. The cover is on. Let's look again where the shadow of the sun is right now. So center of solar eclipse, it's this number right here. Let's write that down again. And what's our next eclipse obscuration number?
Next eclipse obscuration number is 87.5%.
Alright, we will do this quickly. Okay, degrees.
Degrees, 25 degrees, 36 minutes, 40 seconds north. Negative 103 degrees, 45 minutes, and 12 seconds. And you got the negative 103 degrees?
That is with the west. Oops. We still got some time until the next one. We're going to zoom in a little further. Oh, it looks like it's over Mexico now.
Oh, wow.
We're at 80%.
the diamond ring, Bailey's beads, and then second contact. This is all going to happen fairly quickly. Totality, if you're lucky, you'll be able to see the corona of the sun, which is a plasma gas.
Plasma streams from the sun.
You can do a quick sketch of it on this chart. These circles indicate the width of the sun, because sometimes the corona is enormous, and we'll see what our corona has shows us this during this eclipse. Now you're probably not going to want to look away during totality, and you can use your video recorder on your phone to make audio notes, and then after third contact, you can, when you have time in between your measurements, you can listen to your recording and draw your notes. But since we are in a laboratory setting, I'm going to draw the corona as I see it in Stellarium.
We're at 83 and a half.
Looking for 87.5.
84. 84.5. 85. 85.5. 86. 86.5. And we're waiting for 87.5, right?
That is correct.
87. 87.3. 87.45. 87.5. Azimuth is 172. 66. Our next thing we're waiting for is 100, right?
That is correct.
And 100% will be or it will be second contact, not totality yet, or it is the beginning of totality.
100% is second contact.
Yes.
Second contact is the beginning of totality. First contact is when the eclipse begins, and third contact is the end of totality, and fourth contact is the eclipse is ending.
Okay, so up next we're going to be looking for Bailey's beads and for the diamond ring. And those will happen somewhere close to 100%, which is second contact. Stellarium does not simulate Bailey's beads or the diamond ring. So what we're going to be looking for is subtle pixelization on the edges of the sun and moon. And we're going to call those Bailey's beads and the diamond ring, even though they are not actually Bailey's beads and a diamond ring. Let's see your logbook. You should have second contact should be the next thing to fill in, right?
Correct?
All right. We already know the times, so what we're going to do is when those happen, over in the notes field, we're going to say when they actually happened in the simulator, and on the day of, we'll write when they actually happened in reality. %93. 94. Do we want to check where the sun is one more time? Where the shadow is?
Um, if we, yes, write down that, let me write down the numbers. degrees, 40 minutes, and 20 seconds north.
What was the
20
second?
seconds. And negative 100 degrees, 43 minutes, and 0 seconds.
Keep an eye on that number for us while I do this.
Absolutely. You'll move that window over so I can keep an eye on the percentage.
Oh, it looks like it's about to cross the border.
At Radar Base, Texas. %.
If you were taking a photo of the eclipse, this is a perfect time for it. Well, just start snapping photos continuously, or get a good video, or watch the NASA live stream. 98%?
Aware that you may start to hear the howling of coyotes at 100%, and the birds may stop singing. So the crickets may start to act strangely.
99%.
Of this part on our forum where you can make note of what the animals are doing is under here.
Where this pixelization is occurring is most likely where Bailey's beads are going to happen for us. Like I said, the software does not simulate Bailey's beads, so we're just taking this pixelization to be a representation of where we might see Bailey's beads. 99.6, 99.75. Bailey's beads will only happen for about 10 seconds. So we're going to call those our Bailey's beads. That happened at 1:33:09. Alright. Pins down. 100%. And there's that corona. I'm going to switch the ocular so we get a better view of the corona. We are now at C2. And did it happen on time, Anita?
Oh, it absolutely did. It happened on time. And to make a quick sketch of the corona. During the real eclipse, I will be describing this in my video recording on my phone, so I don't look away from the event that is occurring.
When is our center of totality according to our predictions?
Oh, at 13:35.
Okay, we're almost there. 13:35, did it give us seconds?
35:38.
Okay. We're in the middle of it. This is the good stuff. This is what we've waited all day for.
You'll be able to see all kinds of different effects happening on the sun at this point. You will not be wearing your eclipse glasses during totality because otherwise you won't really be able to see it. So this is the only time during the eclipse where you can take off your sunglasses or your eclipse glasses.
And do it according to the NASA safety website. Make sure you
You're
only
in totality.
take them off if you are in actual totality. If you're only getting a partial eclipse, do not. I repeat, do not take off
Do
your...
you see Jupiter?
Yes.
To the right of Jupiter on Monday, we may be able to see a comet called the Doubled Horn Comet.
There's Jupiter.
Oh, I wonder what I was seeing.
That's just a star. So during totality, you may be able to see Jupiter, Venus, and Saturn, and possibly Mars. They'll look like that. And what time is our C3?
3 is at 13:37:50. This is one of the rarest events that a human can see is the sun and the stars in the same sky. It's an incredible phenomenon that I hope we can all experience on Monday.
And the important thing is that the stars you'll be seeing with this eclipse are not the stars you would normally see at night. These are the stars that you would normally see in the fall, since this is happening in the spring. So it's going to be totally different constellations. And what time is our...
13:37:50 is third contact.
All
It's
right.
the end of totality, so it's coming up very quickly.
Just after C3, the end of totality, we may get to see some Bailey's beads on the opposite side of the sun from where they occurred as it was going in.
Picture of the corona.
Oh,
There it goes.
C3. I see a little bead. I see 2 beads, 3 beads. I couldn't see your Bailey's beads being drawn.
My Bailey's beads. Really drawing them in the excitement of the events. Makes them look a little messy, but that's okay.
And what's our next percentage we're looking for?
87.5%.
If we want to do some minute math, we can see how long it took to go from 87% to 100%, and it'll be about that same coming out of totality.
At this point, you can make, you would continue to observe the wonders before you in the sky and make notes about the confused animals out in the outside.
Okay.
During totality, many animals will think that it's nighttime and they will begin to go to sleep. And then as the sun uncovers, the animals will awake, like birds and insects. And of course the coyotes will be howling, so I don't know how well any of the other animals will be able to sleep. But it's just a really, really fascinating event to happen. People in the world haven't actually seen a total solar eclipse. It's rare.
Do you want to check where the sun is right now?
Sun check.
By that I mean where the shadow of the moon is.
We have 31 degrees, 54 minutes, and 10 seconds. North by 97 degrees, 05 minutes, and 40 seconds.
See, it's really gone a long way. It's past Waco now.
Remember how fast the shadow of the moon crosses the Earth, but it is really fast. It's something that we should absolutely Google and look up because it's, I think, 2 NASA jets are going to be following the eclipse, and they're doing science on those airplanes. So that's, it's going jet fast.
And we're looking for 87.5.
Correct.
Most people will think that the eclipse is over now and go away, but we still have at least another 45 minutes to go. And we need all this data logged. We're going to be there for the whole eclipse, rain or shine. And now that it's over in the simulator, we're going to take a quick look at what the weather might be like for our location. Let's see, this is for Austin. Monday, 30% becoming 70%. Chance of thunderstorms, patchy fog, and thunderstorms likely. But we're going to look and see shower and thunderstorms likely mainly after 1 p.m. But since we've done all the calculating, we know that we're going to get to see stuff before 1 p.m. And even if it is cloudy, it's still going to get dark. I'm going to give us a pinpoint forecast for where we are at the Enchanted Rock. It's Blanco. It's a little harder to see in this map. There's Gillespie. Kingsland. You know it's south of there. Yeah. So we're going to say, what's the pinpoint forecast for Enchanted Rock? And it says on Monday, mostly cloudy, then thunderstorms likely. So showers and thunderstorms likely after 1 p.m. It's going to be mostly cloudy. That means there will still be chances to see the sun in between those clouds.
Need is about 6 minutes of clear skies during totality, and some clear patches in between, starting at 12:16. We're at 89%, and we're looking at for 87.5. But the numbers are decreasing because totality is over.
Eight is 7.9. Seven point six. 87.5. Go. On Monday at this point, this is where we're going to be telling tales of how awesome this was and how the clouds parted just in time for us to see Bailey's beads going into totality and coming out of totality.
Going to be able to see the comet that is right next to Jupiter. I believe it, if you look for it, it may be on the right-hand side of Jupiter, between Jupiter and the Sun. Our next number that we're looking for is 75%.
At this point, I'm going to get up and stretch my legs. I'm going to simulate the celebrating that's going on after having seen the eclipse. I'll be back in a moment. What number are we looking for?
For 75%. It's coming up soon. The excitement of our simulated totality has left me drained.
After this next event, I'm going to simulate what it's going to be like texting all of our friends who decided they did not want to show up, and we were the only place in all of Central Texas that the clouds cleared.
I like your positive attitude. 75% is coming up.
78%. 77%. 76%. 3, 2, 1. 75%. At what time did we cross 180 on our azimuth? Because that would have been our solar noon.
Our solar noon happened up here at 1:37:50. The at an altitude of 67 degrees, so that's the highest it's going to be in the sky today. Is at 67 degrees.
That is correct. And what's our next number we're looking for?
62.5 degrees. I mean 62.5%.
All right. Now I'm going to simulate texting my friends and telling them what they missed.
Now, many people have chosen to have a music playlist that revolves around songs that talk about the moon or the sun. I feel that our focus will be so intense that we won't have time for music. In the day, we might actually have to listen to Total Eclipse of the Heart because I think that is the #1 song on everybody's playlist during the eclipse.
We did forget to eat something during the middle of the eclipse because we were so excited. What was that we forgot to eat?
Check. Hold on 1 second. Hi. And these are labeled the Solar Eclipse Survival Kit, which, I think is an invitation to dig in. Now, since this is a simulation, do we have to simulate eating one, or do we get to actually eat one?
I think we just have to simulate it. Those are for the day of.
Oh, and there's 12. And yet we have more than 12 spots on our logbook. Because if you ate one at each point, one person could eat the entire box during the eclipse. I've also heard people are going to be making eclipse or solar eclipse tea, where you put, you make sun tea, but then you drink it during the eclipse.
And what are our percentage we're looking for? 60?
62.5.
Okay. No response from the people who missed the party, but I'm still waiting to see what they say.
Eclipse, you'll want to have access to plenty of water and finger foods so that you can eat quickly and efficiently and not let yourself be distracted by delicious nibbles. .5, that's our next number.
And we are currently at 65.5. We're at 64%.
I may have to grab a snack during our next, after our next data logging.
Too bad you can't have a moon pie.
It's very sad that I can't have a moon pie today.
Bollinger says, I feel sad that I missed the live broadcast. I hope he makes it to the real one.
Absolutely. Shared experiences are better when they're shared.
62.6. 62.5. 195. 66. You may go take a break. We are waiting for 50%. I will watch everything and radio you if anything happens.
Affirmative.
Checking in on the snacking crowd.
I'm having some cheese and crackers.
Sounds like a perfect snack.
Would you like me to bring you some or leave them out?
You can leave them out so that the cheese gets to room temperature, which apparently, according to your logs, is 70 degrees.
Affirmative. What is the temperature of a refrigerated piece of cheese?
Usually around 40 to 45 degrees.
Here is a word problem. If a piece of cheese is at 45 degrees, and the outside temperature is 70 degrees, how long will it take for that piece of cheese to raise to 70 degrees?
I would give it about 30 minutes. We're at 55%.
My battery is dying.
If you come back to the master control room, I will give you a second radio.
Affirmative. crackers to eat.
Commence snacking.
53% left.
I will warn you when we're at 51%.
Affirmative.
We're at 52%. We're at 51%. %. 200. 65. 'And what's our next target?
Target is 37.5%. So some of the other events that will happen during totality, which you should keep your eye out for, are an event called shadow banding, where these black squiggly shadows will race across light-colored environments, and so many astronomers will lay out a white sheet to try to see if they can see the shadow bands. They last for mere seconds, and so they're very hard to see. Another event is the racing of the moon's shadow. If you're in the right point high enough, you can see the actual shadow of the eclipse as it races towards you. And then finally, there's an effect where the colors green and red and blue, I think, they start losing their colors much faster than any of the other colors as totality descends around us.
We've got a long wait until the next one.
Missed the answer to the word problem of how many minutes it would take for the cheese to warm up.
I'm going to give it about 30 minutes.
Affirmative.
I don't know that that's the actual answer to the word problem, but that's what I'm going to use.
Stellarium is an incredible piece of astronomy software that's free, and it is. We use it often to prepare for our astronomy at nights when we want to see what constellations are going to be up. You open astronomy and type in your location, and you can see exactly the location and the order in which the constellations are going to rise during your star viewing session. You can also change the lens. Like right now, it looks like we're looking at the eclipse through a telescope lens, and you can change that lens to a bunch of different elements. Here, now we're using a Nagler 31 millimeter. Using ES 30 millimeter. Celestron Luminos 10 millimeter. A Celestron Micro Guide.
Don't even know what it all means, but it looks fun.
We don't know what it means, but it's something that we will learn about when we get to that point in our lives.
It also allows you to simulate different telescopes. One of them have to see where the next. Oh, there's binoculars. This is what it would look like through binoculars. This is a Celestron 15 by 70 Skymaster binoculars, what you would have seen.
You do not want to be looking at the sun in this stage with your binoculars unless they have a special filter on the end of them, or you have special solar binoculars. Much like these solar binoculars. Eclipse Smart Solar Safe products, Celestron. They're only 2x magnification, which means that it's really no better than just using regular eclipse glasses.
But they're fun anyway.
Yeah, they are fun, absolutely. And they do have two lenses. And you don't have to worry about putting eclipse glasses on these because these are solar safe.
We're looking for 37.5.
Correct.
All right. We'll get there eventually.
Of the most majestic descriptions of an cover the sun uh, is,
From our
from
perspective.
our perspective, of course, is just an astonishing thing.
$37.8. 37.7. 37.6. 37.5. 205. 65. Couldn't hear you on the radio, but that's okay.
The next number we're looking for is 25%. One of the neat things that astronomers will be looking for during Monday's eclipse is, during totality, they will be looking to see if there are any asteroids near the sun, which are normally covered by the light of day. And it's one of those things that is very, very hard to see except during totality. So it's a really great opportunity for very specific scientific events to take place. Many thousands of children will be inspired to become astronomers after Monday's grand event. It is a once-in-a-lifetime opportunity unless you are extremely lucky, or whether you become an eclipse hunter, where you chase down your minutes of totality and travel the world going to the different events, or the different eclipses as they occur across the globe. Every year there's at least two total eclipses. Many times those happen over the Pacific Ocean. I think the next one should be happening in 2026, and then one in 2027, and those are going to be in Europe. We've had preparing for this eclipse, I think we might have to chase the next eclipse in Europe. I mean, it's Europe, so why not? The sun is shining much more brightly. The animals should be a little less confused now after their very short 4-minute nap during totality. I read that during totality, spiders will start disassembling their webs. We don't have any spiders to observe, but if you do have spiders in your eclipse viewing area, be sure to take a look at them and see if that's true.
You can see during this phase that it's not the most exciting thing in the world, but real scientists don't give up, so we're going to stick it out until fourth contact and maybe even a little afterwards.
Fourth contact should be happening at 2 or 14:56:40. So we've got a ways to go. We're looking at 28%, and our target number is 25%, so it's coming soon.
We'll have to go at least 10 minutes afterwards to get that last reading. But this lets you know exactly how long it's going to be tomorrow, or Monday. We're at 25.8. Getting ready for the next big moment. Nope, 25. My mind was wondering. 210 and 64.
Our next target number is 12.5%.
While we're waiting on that, I'm going to do a large screen of the control room. And then we're going to maximize it so people can see your screen and what it looks like when you transmit on your FRS radio.
Very
You can see the screen now.
Hey, well then just let me talk freely. Um, we have my laptop that's set up with an SDR radio, and it captures radio frequencies. And you can listen to radio stations using the SDR radio, and you can listen to people using Morse code, and you can listen to ham radios, people talking to each other. Of course, we are both ham radio operators. Do you have anything to share with the room?
I think we're good. I just wanted people to see that.
The equipment we'll be having out at the Eclipse viewing site are the very tools that we shared with you today. Our logbook, of course, our thermometer, our hemisphere solar tracker that will be mounted on a tripod. We'll be using a second dome because this is our equinox dome, and you can tell because the sun rose at the 90 degrees azimuth point. And we will also have our telescope. And how big is our telescope?
It's about 6 inches.
And the telescope does have a solar filter. We also recently purchased a phone holder that goes onto the lens of the telescope so that the view will display through your phone, which means that you can share the view of the telescope with people just standing or looking at your telescope rather than lining up to look through the eyepiece itself. What other tools do we have? Our light meter. We will have a canopy for shade with our table and a laptop and chairs, a cooler. We will have a sheet staked down to the ground to watch the shadow bands, and we'll have some sheets of paper that have the color red and green on them, so we can watch the effect where those colors change before all the other colors. And of course, we'll have many different eclipse glasses that we can use on our cameras, on our cell phone cameras, to take photos of the eclipse. But we're not going to waste our time taking photos during totality because more photographers have missed the events of totality because they're trying to figure out how to make their cameras work, and they're looking down at their equipment instead of up at the magnificence of the solar eclipse. We also have a device we 3D printed that we did not design, and it is supposed to project the sun onto a plate so that you can watch the sun or watch the eclipse that way. But of course, it doesn't track the sun, so it will need constant adjustment. So, it's more of a 3D printing exercise than an actual scientific tool for the eclipse. And of course, we'll have Stellarium and our logbooks. We'll have this logbook that we filled out today so that we are prepared for each phase of the event. For each phase of the eclipse. And I'm really looking forward to seeing Bailey's beads, the diamond ring, and the corona, just light up the sky. It's an incredible experience. another interesting tool for solar eclipse chasers is there is an atlas, a road atlas, that basically follows the path of totality as it makes its way across the United States. And that's for people who have no fear of driving during eclipses, which I do not recommend. For instance, in the central Texas area, 1 million people have come to this area to watch the eclipse, and 1 million. I mean, our traffic's bad enough, and then you add 1 million people, it's not a good scene. So I can't imagine trying to use the road atlas during an eclipse. But apparently, people do that, and I may buy the atlas after the eclipse, just as a reference tool.
We're at 15%. Our next one is 12.5. Go ahead.
Oh, and everyone out there who has one of our logbooks or printed out one of our logbooks, I encourage you to reach out to us and send us a photo of your filled out logbook. We would love to see how well our logbook worked in the wild. It's doing science like this is so much fun, and we hope to share our love of science with everyone else. And so yeah, share your logbooks with us.
You can reach us on Reddit, where you can post your logbooks, give us a link to it. We're at 12.7. Yeah.
Looking for 12.5. It's almost here.
12.5. 215. 62. Now we're looking for 0% eclipse obscuration. Let's do one more center of solar eclipse so we can see who's in totality right now.
Great idea. All right, 47 degrees, 39 minutes, 40 seconds north.
What was the minute or seconds? It's all the way past Nova Scotia. Getting over there to Newfoundland. That means Saint Pierre and Miquelon is going to have part of the eclipse. All right, we're at 9%. Our next target is 0. I'm going to take a walking around ambulation break. We're at 6%.
We'll admit it is a little harder to stay focused on this half of the eclipse, but see an eclipse in 2027, I think we want to find a cruise ship because cruises can move to a non-cloudy location. And I think that might be the key to our next eclipse.
Why don't we do a quick weather check? Monday, mostly cloudy, then a chance of thunderstorms. After 1 p.m., but still mostly cloudy. And that was for near Fredericksburg. Let's check Austin. (20 to 70). Chance of showers before 10 a.m. Then, slight chance of showers and thunderstorms between 10 and 1. So it's been updated since the last time we looked at it.
Certainly have.
And
Patchy fog.
patchy fog before 11. And when's our first contact?
First contact is at 12:16.
So we'll only be an hour outside of it.
One of the most important things, obviously, about the eclipse is to be safe. And I've heard stories that people who are staring at the sun with non-ISO approved eclipse glasses, you can burn a hole in the retina that is in the shape of the phase of the eclipse that you were staring at the sun, which is just, on the one hand, that's very fascinating, but on the other hand, that's completely terrifying. After our next contact, we will show you how to make sure your eclipse glasses are safer, even if they have the ISO certification on them. They may still be counterfeit. Are at 3%, and we're getting close to our 0%. It should be happening any moment or shortly. We will be going for some time after 0%, because on our logbook we show int plus t, and so we're going to add 10 minutes, maybe 20 minutes. Who knows? We'll see.
I say we go for every 10 minutes.
For how many series of 10 minutes?
Well, since this is a simulated one, let's go for at least one 10-minute period.
Right. Buckle up, ladies and gentlemen. We're going for an additional 10 minutes after our 0%.
But we can, of course, take a break while this is happening, walk around and reflect on all that has happened.
And if you haven't gotten one of our logbooks, you can go to our website and print out a PDF. You can print one out in color or in black and white. I don't know where my black and white one went. Let's see. Oh, here it is. Here is the black and white. I'm going to turn the page. It looks very nice. Print more for your friends and family. It's a great keepsake for this incredible eclipse that's coming up on Monday.
We're at 2%.
You recall from before the eclipse started, we checked our schedule and we got the times for first, second, third, and fourth contact. So we already know that fourth contact should happen at 14:56:40, and now we're just going to confirm that. We also already have the azimuth and altitude. We're going to confirm that as well.
In Stellarium, a bunch of data just disappeared. I think that was where we used to get the where the shadow is. So that means that there's no more totality anywhere.
Yeah, I think that means it has run its course across the face of the globe.
See those percentages just crawling now?
Last minutes of the eclipse. Last seconds.
Yeah, we're at remember it predicted 56, 156. We'll see how close it gets to see if that page, if its math lines up with Stellarium's math. 2 1.1. Zero. And it just changed. And altitude is 60. Wow. All right, we're going to come back in 10 minutes and get another reading on everything. But this eclipse is over. Okay.
We're about to show you how to tell if your eclipse glasses are safe enough for staring at the sun, or rather glancing at the sun.
Moderately safe.
Moderately safe. Step 1, turn the flashlight on your phone. Step 2, cover your your flashlight on your phone with your eclipse glasses. And you notice you can see just a very small point of light.
Anything more than that, and it's dangerous.
And that is the flashlight, and that is the covered flashlight. These eclipse glasses are ISO certified, and it looks like these are not a counterfeit pair. So congratulations to us.
All right, our next
They have
reading.
the word scientific on them.
Oh, okay. Our next reading will happen at 15:06. So let's return by then. All right, quick break.
Right back in 10 minutes. You can observe our screen.
Roger. But how many seconds after it's 56, and how many seconds?
Zero, zero, 1506.00.
Our last read was at 1456 and 30 seconds.
Thanks. So it wasn't exactly 2 minutes.
It was
But
a
it was
little
close.
under, but it's close enough. Close enough for science, right? It is going to. But real scientists will stick it out and do some more T pluses. But we'll do that on the real day. We'll stay extra long for it. So that concludes it.
Like a good plan. All right. Well,
Yeah.
then this concludes
Live
our
stream.
live stream of the simulation of the eclipse that will be happening on Monday. With us for this 3-hour adventure.
3 hours and 15 minutes.
And I hope you learned a lot. And there's my sunspot. There's Bailey's beads. There is the corona. And here are all my notes. Very exciting. Of course, down here you can write in like who you saw the eclipse with, what you ate to sustain your energy, or any kinds of fun things like that. And so I'm closing our the cover of our logbook. And got a lot of